Aloha and welcome back to 3D Printing 101. Today we're going to be going over the details and features. So we already know how to make sketches, the principles of design, how to turn those sketches into 3D objects. But there are a couple more main things that you're going to be using pretty much every day that you're designing that are not necessarily, quite as integral as just making the 3D object itself, but they're very useful. So we're gonna go over the basic ones today. Gonna try to keep it short. Without further ado, let's get into it. So back in Fusion 360, first thing we're gonna do is we're just gonna make a sort of a test piece. So I'm just gonna make line, 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 and line. So finish sketch, and we're just gonna extend this, extrude this on 120. Boom. So we've got this nice little object, but it's not quite as nice as we want it to be. So the first thing we can do to this, which touched on previously, but that's mirroring. So we've mirrored within sketches, but it's also possible to mirror 3D objects because, it's helpful to mirror sketches sometimes, but if you have a fully identical part on each side, if it's actually truly symmetrical, you can save yourself tons of time and usually, because humans make mistakes, usually produce a higher quality part in the end because it's one, your brain power is freed up because you don't have to worry about keeping things symmetrical. But it's also it reduces mistakes down to pretty much zero. So if we go into Create and we click, scroll down a little bit, Mirror. It looks very similar to the mirror tool for sketching, but if we click Mirror, Object Type, Bodies, Faces, Features, Components, we want bodies right now. So if we click on this body, the mirror plane is going to be this guy right here. You can click any plane. It could be, could be this one. It really does not matter. But I think this is going to be the easiest one to go with for right now. In join, you can create a new body as well, but I want to join it. So now this is all still just one body. If you go over here, there's only one body because we clicked join. So now we got mirroring out of the way. Filleting and chamfering. So up here at the top in the Modify tab, you're probably going to see fillet. Now, if you click on the fillet feature, and you click on the side of an object, or at the edge corner of an object, you can pull it in at any given amount, and it will fillet the edge of the object. So rounds the edges of a solid body by adding material to interior edges and removing material from exterior edges. Select edges, faces, or features, then specify a radius. Use the rule fillet type to add fillets based on specific rules. Use the full round type to round the edges over 3 adjacent faces. So, with this, you either do one like this, or you can select multiple edges. So if we click fillet, boom, boom, we can pull it in, and it does it like this. But let's say we had 3, 1, 2, 3. Drag this in. It actually does it like this. So you can alter the way that it does this by there's constant and chord length, but we're going to be using constant mostly. Corner type, you can change this a little bit, and it doesn't always have a huge impact, but I think setback looks pretty cool. Sometimes you're going to want to use rolling ball, but I just personally like setback. Yeah, it's really up to you though. hit OK, and boom. That is how you use fillets. You can also do a very similar thing on the inside of an object. So if you click a 90 degree or less, it doesn't have to be 90 degrees or less, but the part where it goes like this, you can actually just pull it up, and if you keep going, it kind of looks like it eventually starts to look almost flat. But you can it's essentially the exact same thing but opposite. So you go like that, boom. You also have a similar thing, but it's not quite the same, and that's chamfering. So chamfering, if we click this, we can even click new edges, because it counts this entire part that has been rounded over by the filleting as one. You can click basically whatever you want and chamfer that. And the corner type, there's chamfer, mitered, and blend. All of these just depends on what specific project you're working on. I like chamfer. And yeah, I use this a lot of times just to smooth out my parts. I generally tend to use chamfer rather than fillet, although sometimes I do use fillet when I'm dealing with prints, because one, I like the way it looks, but chamfers are easier to print with. Think about it. If you're printing a curved object, something that's circular-ish, there are all these angles that go into that. So with smaller details, it's generally fine, but once you get into bigger fillets, like, you're dealing with angles that your printer can't necessarily handle. So chamfers will generally come out better because it fits into that 45-degree rule, which isn't even the best rule to use because your printer can usually do better than that, but it does fit into the 45-degree rule, so your printer should be able to handle any sized fillet, and it'll just end up looking better in the end usually because it just prints better. Like, what's the use of having something that looks better in the model if it doesn't print better? So that's what I do. You don't have to follow me. You don't have to listen to me. Do whatever you want. But that's my sort of advice. You can also use chamfering, as we talked about earlier, to reduce elephant's foot. Elephant's foot, we talked about way back in Unit 1. But that's basically where the print bows outward slightly, because it could be for a number of reasons, but generally it's because the nozzle is too close to the build plate. So if you add in a chamfer, it essentially cancels out that elephant's foot and it looks relatively flat. So there is our chamfer. I mean, that's pretty much it for rounding and fine-tuning the edges of an object. Another thing that I want to talk about is shells. So we talked about the offset tool, which is really helpful depending on what you're trying to make. But there's also a shell tool. So if we click here, shell, if we read the description of it, shells remove material from a part interior, creating a hollow cavity with walls of a specified thickness. Select faces, then specify a thickness. The selected faces will be removed and the body will become hollow. So what does that mean? Let's say we wanted to hollow out the side of this test part that we've been designing, that we've been working with. We click this part because this is the part that we want to actually get rid of. And so the inside thickness right now is set to 0. But we're going to set this to, let's say, 5 millimeters. So that means 5 millimeters is going to be the thickness of that shell. You'll see what I mean in a second. So 0, 5. So now everywhere, including in the back here, is 5 millimeters. So it adapts to all these curves and everything. Like, this is again, this is one of those things that took me way too long to figure out, but it's really not that complicated, and it's useful in a lot of different circumstances. So shell tool, super useful. You can also, if we, let's say we want to shell here and here, and we set that to 5, it will do the same thing, just more extreme. So now that we know how to use shells, there's one sort of final bit that I would say is a nice detail that's primarily for functionality. Like, you're not going to be using this, maybe you are, but you're not generally going to be using this for looks. This is if you're really trying to design functional parts. And that is threads. So we talked before about holes, and now you can customize those to work with actual screws, and you can thread those and everything. If we were to make a new design, let's design a bolt. It says you can insert fasteners, and they have, like, other people have already created these, and a lot of times you can use those. But let's say we want to create our own fastener. We go here, and this is going to be simple hex bolts. I'm going to use the polygon tool, circumscribe polygon, and this is going to allow me to make a hexagon. And then I'm going to go here, boom, boom, finish sketch. And now we can extrude this 90, and sketches, visible, sketch, extrude, 7. There we go. So this is kind of what a bolt looks like, right? Not 100%, but pretty close. Generally they'll have some kind of chamfer at the top, right? Maybe not that extreme. That's pretty deep cut, but 3 millimeters seems about right. If we go into create, you can click thread. Now if we click on this sort of outer part, it's not going to show up like everything else. It's going to kind of be this funky looking thing, and there are ways to manually do threads, but this way allows you to actually select the thread type. So if we go isometric profile, 24 mil, and all of these selections allow you to design things for actual, functional use. You can take actual screws and completely remodel them in here. You can make things that work with them, nuts, bolts, everything. You can create your own. But if we hit OK, now we have our own bolt here. And yeah, super useful. You can use this in combination with other things that we talked about to make some really, really functional, awesome things. So another, sort of feature that's going to speed up the process a lot is, go back into here. Let's say we want to make a new sketch on this plane. Now, let's see, we want to make a line, and I like the place that line is, but we also want to have some circles, and then we're gonna have this. I don't really know what I'm doing, but this is just for demonstration. It's not actually supposed to be a thing, as you might have guessed. Maybe you guessed, maybe you didn't. Whatever, doesn't matter. So these are constraints, and constraints allow us to control the position. I glitched out for a second. They allow us to control the positioning of different elements on our sketch. So our lines, our shapes, everything like that, we can constrain them. And constraints are actually your friend here, because they allow you to completely control everything that goes on with your design, right? So, the first thing we want to do here, let's say we want to make, first thing we want to do is fix this, because if we don't fix this line, it might have the tendency to move around. But now, we fixed this, so we know that's dependable. It'll stay in the exact same area until we unfix it. We can also click again. We can unfix it, but it's highlighted here so you can see it's fixed. Next thing, probably one of the more useful ones, is midpoint. So let's say we want to move this circle to the midpoint. Click. Just look at the description. Constrains a pointer object to the midpoint of another object. So click here. Boom. It automatically sets, like we just click the point and then click the line that we want to set the circle to be the middle of. It'll just automatically keep it at that midpoint, and we can do let's see, similar things. And then all of these are relatively self-explanatory. And like, let's say I'm not sure about this one, command, boom. It will give me a whole list of information for anything I'm not sure about. So let's just work through a couple of these. So circles, just have a couple circles here, and that's gonna be here, right? So these aren't really aligned in any way, but if we hit concentric, boom, boom, they're lined up now, right? Other ones, let's see, we got a line that's going here and here, and there we go. Like, not really going any particular way. We can just use the horizontal, vertical, and those will set it horizontal and vertical. We can also, if we don't want them to be horizontal and vertical, but we do want them to be perpendicular, we can use perpendicular, boom, boom. Sets them perpendicular to each other. Perhaps we want to make a parallel line to this green one. Oh, whoops, that was not parallel. You can click this one, which will set the two parallel to each other. Maybe you also want to make them the equal size, so we can click this one, and it'll make them an equal size. Let us see. So basically, yeah, we've gone through a couple of these. Tangent might be a little bit harder to understand. If we have a line here, these aren't touching right now. Tangent, click the two, makes them touching each other. So yeah, these are all pretty self-explanatory. Collinear. Oops. So we got line, and then line. If we click collinear, where's collinear? Here. Collinear, boom, boom, mix them, together, linear, line, on the same line. So yeah, those are the main ones that you're going to be using. But hopefully, after going through a couple of these, you'll understand how to use all of them. And it's going to take a little bit of just testing and seeing how things work. But like, really, if you just understand the basics of constraints, it's a little bit higher level of a skill. But if you take 20 minutes, 30 minutes to learn it, it'll save you hours down the line. So constraints are definitely something to look into. You don't need to know them to get started, but they are helpful once you start getting into more intense types of 3D printing. Similar to this is the dimension tool that we talked about before. So you can click these two, and then say we want to make them 20 millimeters apart. Boom, makes them 20 millimeters apart. So those are really the details and features that you're going to be using the most. I didn't want to overwhelm you with information right now, because like, really, you don't need that much. Like, you can learn 20% of the stuff to make 80% of the things that you're going to be making. This is going to take you pretty much like anywhere you want to go with design. And there will be little skills here and there that you'll have to learn, If you are interested in a more in-depth tutorial, let me know. If you just have any specific questions, you can ask me directly, or you can post it in our community so that we can all learn together. But, with that said, great job working through this. I hope I didn't go too fast. If you stuck with me through to here, awesome job. You should have a much better understanding, hopefully, it's my hope, of how to use the details and features of your 3D modeling software. So thank you, and I'll see you in the next lesson.